Hi 242. In this video we're going to finish up our applications of the definite integral by talking about what's called consumer surplus and producer surplus. Okay, so maybe a little bit of a recall here for a second about a couple of functions we're going to need to make use of to talk about these applications. So over here in our notes, I noticed that this first thing I have is that an equation like P equals D of X, that is a price-demand equation for a product, where X is the number of units of product that consumers will purchase at a price P dollars per unit, right? So this is giving you a relationship between the number of items and the price of that item, and it's talking about the demand, right? So it's a price demand equation. So it says if you know the number of items you're going to sell, then you know what the price is going to be, or vice versa, right? So it's all about demand and the relationship between price and quantity when you're talking about demand. Okay, so when we have that kind of a function there, remember we can sketch it. A common one would be something like this, right? If we had a graph, maybe they're at a certain price, or at a certain price, we'll put price over here on the vertical axis, and we'll put demand or number of units over here, right? We'll put number of units of product over here. We'll put price over here. Then a common price demand equation would look something like this, right? Maybe somewhere up here, and then it decreases, right? Like this, right? Because notice here, as price falls, right, as price gets smaller on this axis, the number of quantities demanded increases, right? Okay, and we don't want to do anything to the left here because that would mean X would be negative, and that's bad. We don't want to demand negative, we don't want to sell negative things, right, or produce negative things. So we want to make sure that our X is always positive, which is why this graph starts here on this axis and then moves this way. Okay, and again, as price falls, X increases, moves away, right? Okay, so this is an example of this P equals D of X graph here, right? And so let's just for a scenario, let's say that we had a current market situation where we had a current number of units being sold or purchased and a corresponding current price, right? So let's consider a sort of current situation, right? So let's say that we have currently we have a current price and we have a current number of units. And I'm going to call them something very specific, right? I'm going to say currently, let's say P bar is current price. And let's say X bar is the current number of units. Okay, so in terms of our price demand equation, what that really means, remember, is that P bar equals D of X bar, right? Okay, because that's again the relationship for the price demand equation. Okay, so in this situation, remember that what this says is that there's a current price level set for selling this many product, right? This is the demand at that certain situation. But let's just say hypothetically that you as a consumer were willing to pay more than what the current price is set at, right? That's not an unheard of thing, right? There are products that you would be willing to pay more for, but you don't have to. And for you as a consumer, that's a benefit for you, right? Because you are willing to pay more for something, but you're not going to, of course, tell them, right? You just keep that to yourself and sort of, save that money for yourself. So that's a benefit to yourself, right? And so that benefit is what's called consumer surplus, right? It's a financial benefit on the consumer's part, right? And so we can actually define that here. It says consumer surplus is the difference between the max price a consumer is willing to pay and the actual price that they do pay. So this is actually a financial benefit to the consumer themselves, right? Being willing to pay more than they're actually currently paying. So if we try to think about this graphically now, if we put this current price and current number of units on our demand graph right here, right? If we were to, it doesn't, I don't know where to put it, but if we just put a dot here, so let's pick a different color. Yeah. If I label that dot as X bar, P bar, yes, then what that means is that I have this scenario here where I have this is my current demand level, right? And this is my current price right here. Yeah. So when I think about now the fact that I'm willing to pay more, but I'm actually not having to, right? I'm actually currently paying a price, but I'm willing to pay more, then I can actually see that on the graph there are all of these price points up here that represent paying more, right? This little section right up here represents all of those prices I'd be willing to pay, but I'm not having to, given that I'm currently paying P bar, right? So there may be a graphical interpretation for this, and it's going to represent some sort of shaded area maybe, because notice I have to think about all of these prices that are up in this area, right? So maybe let's see if we can get a bigger sketch here so that we can see exactly how this is going to work. So let's get a big sketch. Big, there we go. Okay, so this is P equals D of X. And let's put our current price and demand levels here. Let's just pick a spot right there. That looks good. So X bar, P bar. And so here is my X bar. Here is my P bar. And for all of these prices up here, you know, these are all the prices I'd be willing to pay. They're all more than what I'm currently paying, right? And consumer surplus is is defined by the difference between those two things, the difference between the max I'm willing to pay, but what I'm currently paying, right? So if I think about how I do a difference here, that's going to be talking about the difference between this value and the value I'm currently paying, right? The difference between this value and the value I'm paying, difference here and here, difference here and here, and I want to add all of those things together. But that's really going to represent this shaded area right here, right? That shaded area right there, okay? And that's an area of the xy plane, right? Well, technically the xp plane, right? But we actually have calculus tools that can tell us how to represent that shaded area there. Now, I know it looks sort of like a triangle, but that's only because of how I've drawn this price-demand equation, right? They might not necessarily look like this. So how would we write that if we were using our skills of calculus here? Well, if you remember back from our area between two curves, that's what we have here. It's the area underneath this demand equation, but above this P bar line, right? And I have a certain starting and stopping place. Okay, so if I were to try to write that area there, I would write it as a definite integral. It would be the definite integral from what to what? Well, I start out at 0 and I go up to x bar, 0 to x bar. And I do top minus bottom. Well, what is the function that's on top? It's the demand equation, right? It's d of x. And then the bottom equation is what? P bar. Okay, and of course my independent variable here is x, so I will write this little dx right there, remember, at the end of our integral. This right here represents that shaded area right there. And this, by definition, is consumer surplus. So this would be our way to calculate consumer surplus. And it represents that shaded area right there. And what does it represent in terms of an application? It represents the total savings to consumers who are willing to pay more than P bar for the product, but are still able to buy the product at P bar, right? And a good example of that kind of a scenario would be bottled water. Everybody, you know, regularly buys a bottle of water for like $1, but I do know that plenty of you have probably bought a $4 bottle of water at some kind of sporting event, baseball game or football game or something like that. And the reason you were willing to pay $4 for a bottle of water is because you were thirsty enough and they wouldn't let you out or bring water in, right? So because water is one of those sustainable things for survival, you're willing to pay more for it than you usually have to, right? So that savings of, you know, maybe $3 because you were willing to pay 4 and only paid 1, that $3 that you save is a benefit to you as the consumer. Okay, so this is our formula here for consumer surplus. If you'd like, we can summarize and write it up nice and big for you, right? So we can write this as if x bar P bar is on P equals D of x, the consumer surplus at P bar is, and we write it as this definite integral. Consumer surplus equals integral 0 to x bar d of x minus P bar dx, right? The function above, top minus bottom, start to stop, 0 to x bar. Okay, and again, it represents total savings to the consumer, and it represents, remember, that shaded area underneath the demand curve but above the P bar line. Okay. Well, just like this is a benefit for consumers, there is an alternative form, which is a benefit to the producers, because the flip side of this is that producers regularly manufacture a product to be sold at a certain price level, right? They would, of course, be willing to manufacture that product for a lower price level, but they don't tell people that, right? They don't say, I'd be willing to sell that bottle of water for 75 cents, but I'm still going to charge you $1 for it, okay? They don't give us that information. They just reap that as a benefit, right? That benefit to them is that extra quarter that they're making off of you. And that is their financial gain here. So the alternative version for this instead makes use of a price supply equation, okay? Because from the producer standpoint, they're producing a product, right? They're not consuming a product. So instead of a demand equation, we have to talk about a price supply equation. Okay, so we have this P equals S of X. It's a price supply equation for a product, and X is the number of units producers are willing to supply at a price of P dollars. So again, X is still number of units and P is still price. But now this is a price supply equation. Okay, so it is the number of units that are willing to be produced at a certain price point. Okay, so we still have the same kind of, well, not exactly the same, but a similar graph that we could do here. Instead, the relationship is a little bit different. So the X and the P, we'll put them here. And the graph for a standard supply equation would look something like this, maybe. Okay, because notice this says that as price increases here, as price goes up, they're going to want to make more units, right? Okay, because they're going to want to say, oh, I can sell them at a higher price, I'm going to make more, right? Okay, and of course we don't want our x's to be negative, so we don't draw any graph on this left side over here, right? Because we don't want x's to be negative, and that's what that would be on that other side of that p-axis. Okay, so here's our price supply equation and its respective graph here. So again, if we say we've got some current situation, right? So let's call again P bar to be a current price. And we'll say X bar is the current number of units again. Then we can again say that the point X bar P bar is going to live somewhere on the function, right, of P equals S of X. Okay, if we just decide to put that point on here somewhere just for visualization, here we go. If I say that's X bar P bar, right, then remember that means that this point here satisfies that equation, right? So that means that P bar is equal to S of X bar, right? So that's good to know, right? Because it's a point on the graph. All right. And again, that also means that I know that this right here is X bar and this right here is P bar. Okay. So when I was saying that there are producers who are willing to produce that product at a lower price, right, than P bar, well, notice that on the graph here I have lots of places where P bar is, or where P is smaller than P bar, right? All of these points down here have their points which their P value is less than the P bar value, right? All of those places down there. And so what we can do is define the difference between the price that is currently being, the items are currently being produced at, and the minimum that they'd be willing to produce those items at, right? That the difference between those two things is going to be a benefit to the producer, right? Just like they're currently producing the bottle of water at $1, but they'd be willing to produce it for 75 cents, right? The difference between the two, the 25 cents, is the benefit that they reap, the financial gain that they reap, right? So here we can define producer surplus, right? It's going to be similar to consumer surplus, except for now we're doing the difference between the current price being produced at and the minimum that they're willing to produce at, right? So in terms of shading here, it's the difference between what? Here and here, and the difference between here and here, and the difference between here and here, right? It's these little sort of vertical strips right here, like that, right? And we add all those together to get this shaded area here. Okay, and how do we represent that using our calculus tools here? Well, we would say I want to define producer surplus, right? Big PS this time. And how do I write that shaded area? It's still an area between two curves, so I'm going to do integral from 0 to, what's my x value? X bar. And now I do top minus bottom. This time it's what? P bar is up here. So P bar is the thing up top. So I do P bar minus, what's the curve below it? What's this curve down here? That's your supply function. That's S of X. And our variable, our independent variable, is X here. Okay, so this is the definite integral that we can make use of to calculate producer surplus. Okay, and what does this represent? It says it's the total savings to producers that are willing to produce at a price lower than P bar, but they produce at P bar, right? So it's the total financial earning or gain that they make from producing at P bar, but being willing to produce at a lower price. Okay, so what you can do is you can be given two of these functions. You can be given a demand and a supply function, right? Each of them, and you can graph them simultaneously, right? Let me make this really big. Here we go. Really big. So what if I were to graph both of these at the same exact time? What if I were to graph a supply graph here? And what if I were to graph a demand graph, maybe something like this? And this is X and this is P, okay? What's interesting is that these two graphs meet, and the place that they meet is given a special name because it's the place where supply and demand meet. Okay, and so this point right here is labeled the equilibrium point. And what we usually like to do is label that equilibrium point as our P bar, X bar. Okay, so that's going to be our X bar, P bar. And I said it backwards, but it doesn't matter. There we go. Well, I mean, it does technically matter, but but the relationship between P and X would remain the same, right? Here we have X bar, P bar written in the correct ordering where X is considered the independent variable and P is the dependent variable. Okay, so if we label this as our X bar, P bar here, our equilibrium point, the place where supply and demand meet, right? Then I can do some really interesting shading here in terms of producer and consumer surplus. Right? Those are our locations for X bar and P bar, correct? Well, remember that consumer surplus is what? The difference between the price that you're currently paying and the highest price you'd be willing to pay, right? The difference between the max price you're willing to pay and the price you're currently paying. So let's go back up here a second, right? Consumer surplus, the difference between maximum price a consumer is going to pay and the actual price that they pay. That was this area, yes? Okay, so that top shaded area, when you graph both of these the supply and the demand functions together, when you graph both of them, that top area there, that represents consumer surplus. And alternatively, where is producer surplus? Producer surplus, remember, was what? It was the difference between the price currently producing at and the minimum, right? So that right here is current price and the minimum when we're using the supply graph. So that's this stuff right down here. Okay. So when you graph both the supply and the demand and you find their equilibrium point, then consumer surplus and producer surplus are easily sketchable like that. And so we don't need to memorize the formulas because if you can remember this picture, right, if you just graph supply and demand, the intersection point here splits this area in half. The top half is consumer surplus, the bottom half is producer surplus, and then you can write the formula for the definite integral for each section, right? And so we don't need to memorize those two pieces. Okay, so for class, I'd like you to read example number 6 on page 777. And that will walk you through an actual example where we are given demand and supply functions and we want to calculate consumer and producer surplus at equilibrium, meaning calculate it using X bar, P bar for the equilibrium point.